So this is the 22nd video on rigid body kinematics. This is in continuation of the 21st video. In this also I'll take up numerical problems on pure rolling. Okay. This will be the last video on the second chapter on rigid body kinematics. This was the longest chapter of rigid body kinematics. This will be the last video. Okay. So I'll write down the question here. Consider the diagram shown below. Consider the diagram shown below in which all the details are given. So see, this is a double cylinder whose center is at C, inner radius is R, outer radius is 8R. There is a fixed horizontal surface over which it undergoes pure rolling. Alright. A string is, inextensible string is folded on the inner cylinder and the string is drawn rightward at a speed V. There is a board This is a board, see, this is a board. It is pivoted at here, this is a pivot. The board rotates about this pivot. Okay, fine. This angle is theta. The center moves rightward at some speed. Okay, and pure rolling takes place here. This is a double cylinder. A inextensible string is folded on the inner cylinder and this string is drawn rightward at a speed V. Now as the cylinder rolls without slip ahead, this board will tend to rotate like this. So board will have some angular velocity, say omega, say. Okay. The question is you have to find the angular speed omega of the board in terms of the given quantities. Find omega in terms of V, R and theta. Find omega in terms of V, R and theta by several methods. Okay. So as the cylinder moves ahead, double cylinder, this board tends to rotate clockwise at some angular speed omega. Now we have to determine omega in terms of V, R and theta by several different methods. Okay, fine. So now this can be solved in several ways. Okay. In fact, it can be solved in several different ways. You can solve this question. Fine. So now question is how to solve it. The solution. Method 1, M1. Method 1, that is M1. Alright, fine. Method 1, M1. Method 1 is by applying SRC. Okay. See, suppose the angular velocity of drum is omega naught, say, in clockwise sense. See, center moves rightward, so for pure rolling here, omega naught should be in clockwise sense. Okay. And suppose here, P is a material point of the, D is a material point of the drum, which is in contact with material point P of the board. This is a board. So D is the material point of the double cylinder, which is in contact with material point P of the board. Now see, here the cylinder and board are in contact. This is the common normal at the contact point. Since P and D are in contact, component of velocities of P and D along the common normal should be equal in magnitude and direction both. There is a necessary condition for maintaining the contact at this point. So for maintaining contact at this point, velocities of material point P of the plank and velocity of material point D of the drum in contact along the common normal should be equal. So what we must do, we must find the velocities of P and D along common normal and equate them. We must find the velocities of P and D along the common normal and then equate them to get the required omega in terms of the given quantities. Fine. So first, what we must do first now? First, let us find the velocity of P. Now you can see P is at a fixed distance from the pivot. So as the board rotates clockwise, P moves in a clockwise circle with pivot as a center. And radius equal to this distance L, which is not given, which we can find by geometry. Alright, fine. So velocity of P will be by theory of circular motion omega into this distance. L is not given, L has been assumed. Now how to find L, that is the question. See, from C I drop the normal here and I drop the normal here also. And this pivot I join to the center. Now this distance, these are perpendicular from C on this and this. This is tangent, this is also tangent to this double cylinder. So this is eta, this is also eta. So this line bisects this angle by geometry. So this angle becomes theta by 2. This also becomes theta by 2. This is L, so this is a tangent from here to here, it is tangent, length L. So this distance is also how much? L, tangent. This also is equal to L. Now you see, in this right angle triangle, this is eta. Eta by L is equal to tan theta by 2. In right from geometry. Tan theta by 2 is equal to 8r by L. So L becomes 8r cot theta by 2. So this L is substitute here. Velocity of P becomes 8 omega r cot theta by 2. Alright, this is Vp. Vp becomes 8 omega r cot theta by 2. Vp becomes 8 omega r cot of theta by 2. The velocity of this point P is normal to the radius joining P and P, normal to the radius. That is the line joining P and the pivot. So the velocity of P should be along common normal. This Vp itself is along common normal at the contact point P and D. It is along the common normal. Okay. Now we have to find the velocity of Vd along the common normal and equate them for the maintaining contact. For what we do, we apply SRC between C and D. Okay. Now to apply SRC between C and D, we have to find Vd. So we must know the velocity of center C. That also has to be determined. Okay. We have to know the value of Vc. Vc we have to know. Vc. The question is how to find the value of Vc. Now see, here also we can, if you want, we can find Vc by SRC, or we can apply section formula also. That is also very good. Okay. So what I apply the section formula. Okay, fine. See, here this is a string. This is a point D1 of the inner cylinder which is in contact with the string at point S. So this string is moving at a speed V. Here again I assume that between the string and the inner cylinder it is no slip. This point is also moving at what speed? V. Because S is moving at V, this point should also move at the same speed V. No slip we assumed here, no slip. Alright. So what I do? I draw the line joining D1C and this contact point D2. Okay. So see, I'm repeatedly telling you can apply SRC also and get the answer. But I am applying section formula. Okay. Just for sake of familiarity, for different methods I am illustrating. So this is D1. This is equal to C. And this is equal to D2. Now C to D1 is how much? C to D1 is just equal to R. This is R. And C to D2 is how much? C to D2 is how much? 8R. Now velocity of D1 is what? V. Because I have explained just now. And this point is at rest because undergoing pure rolling on a fixed surface from pure rolling criteria. This point D2 of the loop, this drum at this contact point is rest. It is at rest. And Vc is in rightward direction Vc. Okay, fine. So this is R, this is 8R. Alright, fine. So VC, this center C divides the line joining D1 and D2 internally in the ratio 1:8. Lambda is 1, mu is 8. Lambda is 1, mu is 8. R and 8 are. Lambda becomes 1, mu becomes 8. So VC is just lambda times velocity of D2. Lambda into velocity of D2 is 0, pure rolling criteria. Plus mu times velocity of VD1. Mu is how much? 8. 8 VC1. 8 VD1. That is simply V. By lambda plus mu. That becomes how much? 9. So VC becomes 8 V by 9. This we have found, alright. VC becomes how much? 8 V by 9, that is VC. Alright, fine. So I'll rub this one, okay. So I've applied section formula here. This is R, this is 8R, okay. This is R, this is also 8R, okay, fine, it's alright. So I applied section formula. VC is equal to 1 into 0 plus 8 into V by 1 plus 8. So VC is 8 V by 9 in rightward direction. Okay. Now what I do? I apply SRC for velocity between C and D. Okay. So SRC apply between C and D I apply. So it's like this C. So C becomes the selected point and D becomes the other point. This is C, this is D. Okay, we give the velocity of C to D. Velocity of C is how much? VC. So I give VC. Then what to do next? Then I write down the sentence. This double cylinder rotates at angular speed omega naught clockwise. So point D moves in a clockwise circle with center at C and radius 8r. So for this I gave omega r, omega naught r, omega naught into 8r, sorry. I give a velocity of omega naught into 8r to D along tangent. Okay, fine. So this angle is theta. So this angle also my geometry is theta, corresponding angles. The velocity of D along is vectors on these two. Now common normal at this contact point is along this direction. Okay, so velocity of D along common normal is simply Vc sin theta because omega naught into 8r has no component along this direction. It is at right angles to this. Omega naught into 8r is along tangent, right angles to this line. So it has no component along this direction. Only Vc has a component. So component of velocity of D along common normal is Vc sin theta. Vc sin theta. And that is also a common velocity of point P of the string of the board along common normal. Just 8 omega r cot theta by 2. 8 omega r cot theta by 2. Okay, fine. So from this we see that Vc is how much? 8 omega r, 8 omega, okay, fine. This is a little bit, okay. So now we have to find omega. Okay, of Vc is how much? 8V by 9. So this Vc I substitute here. 8V by 9 into sin theta. Sin theta becomes cos sin theta. 2 sin theta by 2 cos theta by 2. Okay, is equal to 8 omega r cot theta by 2 becomes cos theta by 2 upon sin theta by 2. Okay, so from this you see cos theta by 2 goes away and 8 and 8 also goes away. So from this we get omega. So omega is how much? Sin theta by 2 comes here to 2v sin square theta by 2 upon 9r is therefore the required answer. So this was the solution by first method, okay. So omega becomes how much? 2v sin square theta by 2 upon 9r. So this is the value of omega. Fine. So omega becomes 2v sin square theta by 2 upon 9r. That is the required value of omega. So omega is equal to 2v sin square theta by 2 upon 9r. Okay. This is therefore the required answer by method 1. Alright. Now I solve it by method 2. Okay. Method 2, what I do, I use the method of calculus. Okay. By using calculus. Method 2 I solve by the method of calculus. Okay. See, VC we have already determined. VC was how much? VC was 8V benign, no? Okay. VC was equal to 1 into 0 plus 8 into V. Yes, 8 into V. So we have found, method 1 we found VC was 8V by 9. Okay, fine. Now see, this VC is directed in rightward direction. The center C moves rightward at a constant speed, at a speed of 8V by 9. Now suppose we take the pivot to be the origin and we take this direction to be x-axis. Velocity of VC is along x-axis. So its velocity can be written as dx by dt, where x is the x coordinate of center C. Now from this you see, this is 8r. This is 8r. This angle is theta by 2. So x coordinate of C becomes 8r cot theta by 2. So x coordinate of point C is 8r cot of theta by 2. That is x. X is equal to 8r cot theta by 2. That is the value of x. Okay. So we differentiate it now. Dx by dt. 8r comes outside. D by dt of cot of theta by 2. Okay. So this becomes 8r. D by dt of, we apply the chain rule. D by d theta of cot theta by 2. That is minus half cos square theta, cosec square theta by 2 into d theta by dt. The angular speed of drum is omega. Now you see, as time passes by, theta decreases. As the drum rotates like this, theta decreases. So theta decreases as time passes by, which is means that d theta by dt is negative. So omega is equal to magnitude wise, if you write, then omega should be minus d theta by dt. Omega should be how much? Minus of d theta by dt. Okay. So this omega is substitute here now. Alright, fine. Omega is the angular speed of the board, okay? So minus d theta by dt is omega. So minus d theta by dt becomes omega. And Vc is 8V by 9. So 8V by 9 is equal to, this becomes 4r. Minus d theta by dt becomes omega. This becomes 4r into cosec square into omega. So from this we see that omega is equal to 2v by 9r sine square theta by 2. Okay. So omega becomes 2v sine square theta by 2 upon 9r. Same answer has been obtained here also. Fine. So I solved this problem also, I have solved. Okay. So now I have taken 22 sessions on rigid body kinematics. So 2 chapters of rigid body kinematics have been fully covered. Okay. And now we have to pass over to the 3rd chapter. So in the next session, next video I'll make on this 3rd chapter, SRC procedure for acceleration. And then the last chapter will be on instantaneous center of rotation. And then rigid body kinetics will then be over. Okay. So you carefully go through these problems. Okay. If you understand them and you take a problem from any other source, I'm sure you'll be able to solve it. There's no doubt about it. You don't have to go anywhere. You don't have to go any coaching institute. You don't have to go outside the town also. Here itself, and by seeing this and understanding it and taking a problem, so you can solve it on your own. And in case you have difficulty in understanding, write in the comment box. Okay. I'll look at it and then try to help you. Okay. If you have any difficulty in understanding it or you have doubts of your own, you just write it in the comment box. I'll look at it and try to solve it out. Okay, fine. So I close it here.